Welcome back to B Spice. In this session, we'll discuss about the instrument standard drawing, wherein we'll focus on the standard drawing, the typical drawing for instrument impulse tubing. Okay, so this is one such typical drawing. We will see the details of all the types and also the based on the different types of measurement, whether it's a flow, differential pressure, or pressure gaseous service, steam service, all these water, liquid service, everything we'll see one by one. Okay. So basically, this drawing actually is prepared and highlighted with the impulse tubing from each process fluid. In the sense, liquid, gas or vapor, and steam service for each type of measurement like flow pressure, differential pressure, and level. So typical arrangement of the impulse tubing also, how you are routing, what is the slope, and also the work demarcation between the instrument group and other discipline. All those details will be part of this drawing. Okay, let's move on with the details. See, this is actually support for the instrument lead piping. How we are doing the support. For example, you have your orifice here, right? You have this tapping and isolation valve and the tubing are routed like this with a sufficient slope, and all along using the structure it has to be routed, right? This is how it has to be. So if you see the section view of this, you see if it is a piping, we use pipe also, we use impulse tubing also. So if you're using a pipe, so this should be the way forward for the support. See, using the steel angle, you have the pipe support, and you using this connecting what you call U bolt, you can mount like this. And if you are using a tubing, this is how it has to be. You have the saddle here, right? Yes, we call it as the clamp with vinyl cover. Yeah, and this is how it has to be. This is your tubing, and this is your angle. So this is one such example for instrument lead piping. Now we will see the different types of pipe methodology or routing based on the flow, measurement. So meaning flow or pressure or differential pressure. So in this case, it's a flow instrument. And if you are using a stainless steel tubing, so then this is how actually, this is for the gas, vapor and condensable service, vapor, liquid service, all these gas service, vapor and condensable gas service, and vapor liquid service. This is how it has to be. So as you can see here, this is your pipe and your orifice, and after this isolation valve, and this is all going all the way and transmitter. So it's mounted up actually. Okay. So that is a point. And another typical arrangement is this one. This is actually typical venturi. This is also for gaseous service. And another application is this one, gas service. And this is a different actually. We also sometimes we use like this actually. You see here, same level, we have taken the tapping and it is routed and mounted here actually. This is also one of the type of application. Then you have the uh, what do you call steam service. So as you can see here, you have a condensate pot. If the temperature exceeds 200 degrees C, then you have this seal pot. And if your temperature less than 200 degrees C, no seal pot. But the point is, this is tapping. You have to elevate here. You see the tapping, it's a direction upwards, right? Then after that, it bring it down using the slope. Same here also. So this is one such actually. Predominantly, as per my understanding, we use these two actually scenarios. So for gas service, it will always be up actually. Steam service, it will be like this. Okay, right. So then if you are using a piping, okay, flow instrument, if you are using a piping, same actually, but only thing is this guy will be a piping. Same. Gas service, gas service. This is for orifice, this is for venturi, and this is a gas service, typical gas service. But this is piping actually, not the tubing. And this is for the steam service. Same, the condensate pot, all this, and your transmitter is. So this is one such aspects related to flow instrument piping. Okay. Then we go into the flow instrument, again stainless steel tubing. This is one, a liquid service. You see here, liquid service. So it is bottom, right? Yeah, orifice, the tapping, slope, and it is bottom, right? The instrument is on the low level. Same for liquid service, orifice. So this is also liquid service. So this is a different type of arrangement. Okay. Then we talk about the liquid service, and this is another type actually. See, this is for the liquid consisting of two or more components. It's a mixture, right? So for that, we will have this kind of what do you call methodology. Okay. Right. Then flow instrument piping, same piping, similar arrangement only. Only difference is this piping. Okay. I hope this is also clear, right? Yes, similar to that instrument tubing. Only difference is here piping. Okay. That's why I'm not explaining many in detail. Right. Now I go to the differential pressure instrument SS tubing. So you have three types here. So this is for the gas service. See, here differential, right? Two lines, and it's connected to your instrument with a sufficient slope moving upwards, right? Yes. Then this is for the gas service. Again, this is on the vessel. This is on the pipe, and this is on the vessel or tower. So you have a high tapping and low tapping and connected to the instrument with all equality, everything. So the point is the instrument is on the top because of the gas. Okay. Then liquid service. This is on the pipe, and instrument is on the bottom. That's the point. So this is the differential pressure instrument, stainless steel tubing. Okay. Now differential pressure instrument piping. Same case actually. Same case. Only difference is this piping. Instead of tubing, this will be the piping. Okay, friends. So this is gas, and this is also this is liquid. And this one is a capillary. Capillary and diaphragm seal. Capillary and diaphragm seal. Okay, this is how it looks. Okay, good to go. Right. So now we'll focus on the pressure instrument tubing, stainless steel. So this is just a single tapping and gas service. So this is on the top, then liquid service, this is on the bottom. Okay. Then this is the steam service. This is also on the bottom. Okay. Then you have this PCV1, right? This is actually for a self-operated valve, a self-regulating valve. This is the typical look and feel. And if it is a draft gauge used for the furnace, this is how it has to be. You have an isolation valve. Then from the tapping, you have to take and connect it to your draft gauge. This is a pressure instrument, stainless steel tubing. Then similarly, pressure instrument piping. So no change, only except this will be piping. That's it. Additionally, we have one option, method, this one also. Instead of draft gauge, I have actually given the pressure switch. Pressure switch tapping also will be like this. And if you are going for a diaphragm seal type, this is how it has to be using a capillary. Okay, right. So that is about the pressure. Then level. We are using stainless steel. Okay, so this is your one typical. So level, and this is dry leg service. It will be like this. Okay, the instrument here, and this is wet leg service. Yes, and wet leg service, you have this pot also here. This is on the yeah, this is also there. Then you have a dry gas service. So this is on the top. This is on the top, the instrument on the top. Then you have open vessel. It will be like this, and because the LP open to atmosphere, right? High pressure is connected and LP open to atmosphere. Then for closed vessel, this is how the configuration. And this is for the bubbler type. If it is using a bubbler type, it will be like this actually. And you should have a air supply connectivity also. So this is a level instrument service, tubing, and this is level instrument piping. There is no change actually, same as what we discussed for the level instrument tubing, and this except the change is only in the piping. Okay, so I hope you got some idea on this. This is just a typical. See you in the next video. Okay, take care. Bye bye. Few more interesting topics are coming up. I'm planning to take something on the IP rating chart, and also the protection method of protection, flame proof, explosion proof, all are going to come. Stay tuned, and yeah, thank you. Bye bye. Take care.